Hey guys, this is Dr. Callahan with week 13 Thursday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. All right, let's go ahead and get started with today's stuff. So here is the breakdown of what you're supposed to be doing. All right, so with that said, let's go ahead and continue with our stuff today. Your guided notes is going to look something like this, which I'm actually not going to show you guys just yet, just as an introduction or as a summary. In the last few days, we talked about mean, median, mode. And so just to go over this, the mean is a numerical average of the data set. And how you go ahead finding the mean is by adding all of the numbers together, count the numbers of data that you have, and then divide it by the sum by the number of values. The next one, part of central tendency, is median. And the way I remember this is median is the number in the middle. And it depends whether you have an even number or an odd number, because if you have an even number, or excuse me, if you have an odd number of data, then that number is just going to be the number in the middle. And in order to find that, you have to first rearrange a number from from the smallest to the biggest. Now, on the other hand, if you have an even number of data, you will end up with two numbers in the middle, and in which case you can either make a guess about the number that's in between those two numbers, or to be more precise and accurate, you will have to add them two together and then divide by two. So just as a quick little review, on your table or on your desk, these are Abby's science test scores. Find the mean and median, and then write the score on your desk. Pause the video. All right, so to find the mean, we're going to add all of her scores together. She has taken 9 different tests in the last 9 weeks, divided by 9, and her average or her mean is 87%. Now, to find the median, the middle number, let's rearrange her scores from smallest to biggest. And as you can see, 9 is an odd number, so the number in the middle is just going to be one number in the middle. And in this case, it is 88. So another way of remembering this is think about median sounds like medium. Think middle when you hear median, because it is the middle size shirt in between a small and a large. Now, on the other hand, if Abby's scores were an even number of data, what would you do then? You will add the two numbers and then divide by 2. So for example, if she had 8 tests rather than 9, and the middle number between 88 and 95, if you're really good at making a guess, that's awesome. But if you want something that's a little bit more precise and for sure is the correct answer, you add 88 and 95 divided by 2, and the middle number is 91.5%. Okay, so that takes us to the standard deviation. So what is standard deviation? That's the next topic that we're going to be discussing. Standard deviation shows the variation in data, and variation refers to how spread out they are. If the data is close together, the standard deviation will be very small. If the data is more further apart, then the standard deviation will be very large. So going back to Abby's test scores, well, from 63 to 100, that's a pretty big gap. Well, in between them, what about 84 to 88 and 95 to 97? So it's basically talking about how spread out are Abby's test scores for the last 8 tests. Standard deviation is often denoted by this the symbol. It's the lower Greek letter sigma. So it kind of looks like a little circle with a line on top. And we use it by representing it on a bell curve. Under this bell curve is going to be 100%. Now, if most of the students, another good way of thinking about bell curve is like students' height, for example. If you're over here, that means you're obviously very tall. And if you're down here, it means you're short. And then if you're right here in the middle, that means you are average. So specifically, if you're talking about one standard deviation from the mean, it is oftentimes 34 plus 34, these two sides right here. This side is above the mean, which means you're taller than the average. This part is below the mean, which means you're shorter than the average, but not by much. These two added together is going to be 68%. Two standard deviation is between this piece right here and this piece right here and this entire curve underneath the bell is 95%. And then 3 standard deviation, which is this entire thing right here, with the exception of this tiny little sliver of space that you actually don't see, is represented by 99th percentile. So there are certain steps to find the standard deviation. Here are the 6 ones, so go ahead and read it. And oftentimes you use this formula, which looks very complicated and kind of intimidating, and I understand that. So rather than doing all of this work, I've decided to go ahead and put on a table for you guys to make it a little bit more easier for you to take a look at. All right, so with that said, this is a handout of what you should have in class. We're going to fill in the blank for a few things, and then we're going to do a question about standard deviation. So our goal today is to determine the range of set of data and also determine the variance and standard deviation of a population of a sample. So first things first, range is how far apart the data is. And oftentimes, if you guys remember, it's always the biggest number minus the smallest number. The difference between the maximum and minimum data is going to give you the range. So for example, a corporation hired 10 different graduates. Their starting salaries for each graduate is as follows: 41,000, 38,000, all the way over here to 42,000. So to find the range of the salary, as in like what is the difference in between the biggest number and the smallest number, you look at the highest salary, which in this case I believe is 47,000, and the lowest salary, which is at 38 or 37,000. So if I subtract the two, the difference is going to give me $10,000 difference. Okay, so then let's talk about deviation, which is how far an entry is from the mean. The difference between the data X and the X bar, which means mean of the data set, is going to be the population set. The sample data set is X minus X bar. Now use the starting salary from example 1 to find the standard deviation of each of the entries. There are 10 different people. The X bar is going to be the total of their salaries divided by 10 because there are 10 people. If I add up all of their salaries and I divide it by 10, it will be $41,500 a year. So now what I want you to take a look at is take a look over here. Put a star next to all the salaries that have a positive variance, and then put a box around the salaries that have a negative variance. And what does that mean? So with all the ones that have a positive variance, that will be this one, this one, this one, this one here. And a box around all the ones with a negative would be this one here, this one, and this one. So what does that mean? That means people with a star are making above average, and people with a negative are making less than the average of what somebody is making. Okay, let's go ahead and take a look at the next part of this. Okay, standard deviation, looking at this part here, is going to be the measure of an entry deviating from the mean, the average of the deviation. The more entries are spread out, the greater the standard deviation. The sample standard deviation uses the symbol S. Population standard deviation uses this little kind of a circle with a line on it. So then here I have 3 different scenarios. The first one here is not spread out at all. Okay, the variance is literally 0 because the data is just not spread out. The second one, it's kind of like a better spread out. This one is definitely has like a variance of maybe 1 or something, 1.2. This is kind of like your grade. Not a lot of people have A's, not a lot of people have F's. A lot of you guys are right here in between B, C, and D. And this one right here is probably going to be a skewed standard deviation because you have a lot more answers, a lot more people on the end rather in the middle. Okay, so variance is another way of measuring spread. It's the value of the standard deviation squared. It's not as useful to the purpose. And these are the symbols that you would use. So with that said, let's go ahead and fill out the chart. So we're going to be on example 3 right here. All right, so then what we're going to do is, as we recall from the last example, there are 10 different people that graduated. So the first thing that we're going to do in this situation is we're going to take the first person's salary. We also determined that the mean or the average salary is 41.5. So we're going to subtract that from everything, which we just did, okay? And then we're going to take this number here with your calculator, and you're going to multiply it twice, okay? So you're going to do a negative 0.05 squared. And keep in mind that that's equal to negative 0.5 times negative 0.5. And you're going to be putting the numbers here for all of these. And let's fill that part out. So pause the video and do that. So at this point, you should have something that looks like this. And now what we're going to do is we are going to add all of these numbers here because the sigma here means average. So we're going to add everything here that I'm putting in this box. So pause the video, add everything together. And your average in this situation should be 88.5. This right here is going to be your variance. Not quite, that's your sum. You're going to now take the variance, which means you're going to divide it by 10. So I'm going to take the 88.5 divided by 10, and that's going to give me an 8.85. And then from there, I'm going to go ahead and square root it, which will just give me the variance, or excuse me, the standard deviation. And your standard deviation in this situation is 2.97. All right, you guys, so let's go ahead and try to maybe practice this for a little bit. So here is your second one. And what I would like you guys to do is to go ahead and fill out the charts. So first thing I'm going to do is, if you take a look at this, example 1, which I've kind of shown you the steps, you're going to take all of these numbers here, add it together, and then divide by 1, 2, 3, 4, 5. That's going to give you the average, which is the X bar, and that's what you put here. Then you're going to specifically subtract the two away from each other. So 12.6 minus 15 gives you this. 15.1 minus 15 gives you this. I'm going to do that for the entire table. And then you're going to multiply these by itself. So negative 2.4 times negative 2.4, which gives you 5.76. So then fill out the rest of the table here. Then after that, you are going to add up everything here together. That's going to give you the sum on top. But then you have to take that sum and then divide it by 5, which will give you this number here. This is your variance. Then when I square root that variance, it's going to give me my standard deviation, which is 2.79. So now that we have done one together, I would like you guys to go ahead and complete data set 2, and then so on and so forth with the rest of these here. If you feel like you need some extra credit practice, I do have the third page right here, but it's not mandatory. All right, so then to give you some additional practice with standard deviation, we're going to go back to here. And I am going to have you guys do a quizzes on the practice for this. So you are going to go to joinmyquiz.com and then type in 07199026, and that is going to be your code. There are 12 questions. All right, you guys, as always, I hope you have a wonderful week. I will see you guys next time. Take care.